Three laws, just three laws, rewrote the entire history of science. Before Newton, the world believed that motion was mysterious. Planets moved, apples fell, arrows flew, but nobody truly knew why. Then came Sir Isaac Newton, a young man sitting under an apple tree, and what he discovered would shape everything from rockets and cars to how we understand space, gravity, and the universe itself. Today, we'll break down Newton's three laws of motion in the simplest way possible and see how they completely transformed physics forever. For thousands of years, people believed ancient ideas from Aristotle. They thought objects stop moving because that's their natural state. They thought heavier objects fall faster than lighter ones, and they believed the heavens operated under different rules from Earth. No one connected the falling of an apple to the motion of the moon. No one connected a rolling cart to the movement of a planet. Physics was philosophy, not science, until Newton. Newton's first law is called the law of inertia. It says an object at rest stays at rest, and an object in motion stays in motion unless an external force acts on it. This seems obvious today, but it was revolutionary. Think about a football. You kick it, it rolls, and then it slows down. People believed objects naturally stop. Newton said no, objects only stop because forces like friction and air resistance slow them down. Remove those forces, and motion continues forever. To prove this, look at space. There's almost no friction. A spacecraft doesn't need to keep burning fuel to move. Once it's in motion, it just keeps going. For millions of kilometers, this first law is the foundation of everything in physics. It explains why seatbelts are needed, why satellites stay in orbit, and why your body jerks forward when a car suddenly stops. Inertia is everywhere, and Newton made the invisible visible. Newton's second law is the most powerful of all. F equals ma, force equals mass times acceleration. It's not just a rule, it's the first time in human history that motion became mathematics. This law tells us how fast a car accelerates, how a rocket lifts, how much thrust a jet engine needs, how strong a bridge must be, how planets move, how bullets travel. Everything in engineering depends on this law. Let's break it down simply. More force means more acceleration. More mass means it's harder to accelerate. Imagine pushing a bicycle, easy. Now imagine pushing a truck, much harder. That's F equals ma in real life. This simple formula is the heartbeat of modern engineering. Without it, no airplanes, no skyscrapers, no machines, no robotics. Every time a rocket blasts off into the sky, Newton's second law is working harder than anything else. Newton's third law is famous. For every action, there is an equal and opposite reaction. This is the law that takes us to space. A rocket pushes gas downward at high speed, and the opposite reaction pushes the rocket upward. That's it, no magic, just action, reaction. The same law explains why guns recoil, why birds fly, why you move forward when walking, why a balloon flies around when you release the air, and why a swimmer moves forward when they push water backward. The third law is everywhere in sports, vehicles, machines, even in your daily movement. This law gave birth to the age of aerospace. Newton didn't stop at the three laws. He asked a bold question. If an apple falls to the ground because of gravity, why doesn't the moon fall too? His answer changed the world. The same force that pulls an apple down keeps the moon in orbit. Newton united the heavens and the earth under one set of rules. This was the first time humans understood the universe as one system governed by the same physics. This moment was the birth of modern science. Newton's laws are not old ideas, they are alive in every technology around you. Your car uses them, your phone sensors use them, airplanes fly using them, rockets depend on them, engineers rely on them, animation and gaming physics engines are built on them. Even scientists exploring black holes and galaxies use Newton's laws as their starting point. In just three laws, Newton gave humanity the tools to understand motion, build machines, and explore the universe. He didn't just change physics, he changed the world, and it all started with a falling apple. Thank you for watching.